Alright, in this video I'm going to be solving the CIE A-Level Maths 9709 question paper 13 for October-November 2024. If you're feeling anxious, overwhelmed, or unsure where to start, then I've created a complete course that streamlines everything with step-by-step videos, interactive quizzes, and an exclusive student community to keep you on track. You can get access to it by clicking the first link in the description. Otherwise, like the video, subscribe, and let's dive right in. Question number 1. An arithmetic progression has 4th term 15 and 8th term 25. Find the 30th term of the progression. Alright, so we're given that our 4th term is 15. So U4 is equal to 15. And we're also given that our 8th term is 25. So U8 is 25. And we know that we're dealing with an arithmetic progression. So our formula for nth term is un is equal to a plus n minus 1d. And you can find this formula in your MF19. Okay, so using this formula, we can create two equations using these bits of information. So U4 would become a plus 4 minus 1d, so a plus 3d, and this is equal to 15. And then U8 would become a plus 8 minus 1, so 7d, and this is equal to 25. Now we've got two equations in terms of a and d. So we can solve these two equations simultaneously to find a and d. And then once we have a and d, we can go ahead and find the 30th term of our progression. So let's start by making a the subject of the formula in this equation. So a is equal to 15 minus 3d. So we can go ahead and replace this a with 15 minus 3d. So that we've got 15 minus 3d plus 7d is equal to 25. So that's 15. You've got 7d minus 3d, so that's positive 4d, and this is equal to 25. And so here we get that 4d is equal to 25 minus 15, which is 10. So divide both sides by 4, and you get that d is equal to 2.5. And to find a, we can substitute into this equation. So a is 15 minus 3 times 2.5. Punch that into the calculator. So that's 15 minus 3 times 2.5. And that gives us that 7.5. So now that we've got both a and d, we can go ahead and find the 30th term. So to find the 30th term, that's going to be U30. We can use the formula for nth term. So that's a plus n minus 1d. A is going to be 7.5 plus n minus 1, so 30 minus 1, which is 29, multiplied by a common difference, 2.5. Punch this into the calculator. That is 7.5 plus 29 multiplied by 2.5, and this gives us 80, and that's our final answer. Number 2. Find the exact solution of the equation cos 1/6 pi plus tan 2x plus root 3 over 2 is equal to 0 for x is between negative a quarter pi and a quarter pi. So for starters, what we could do is to use our calculators to evaluate cos 1/6 pi. That should give us an exact value, and make sure that your calculator is in radians. So cos 1/6 pi, that gives us root 3 over 2 plus tan 2x plus root 3 over 2 is equal to 0. So we can add root 3 over 2 to root 3 over 2, which gives us 2 root 3 over 2, which is just root 3. So we've got root 3 plus tan 2x is equal to 0. So this would become, we're solving for x. Remember, we want to solve the equation, so we're solving for x. That's tan 2x is equal to, subtract root 3 from both sides. So you've got negative root 3. And then now we can take arctan on both sides, so that we've got 2x is arctan of negative root 3. Let's evaluate arctan of negative root 3 using our calculators. That should be an exact value as well. Indeed it is. It is negative 1/3 pi. and multiply both sides by 2 to get x. So you get that x is negative 1 over 6 pi, and this does fit within the given interval. So this would be our final answer. Number 3, part A. Find the coefficients of x cubed and x to the 4 in the expansion of 3 minus ax, where a is a constant. Give your answers in terms of a. Okay, so let's start with the term in x cubed. So we know that if we want to find any term that's from the expansion of something of the form a plus b to the power n, it's going to be n choose r times a to the power, that's n minus r, times b to the power r. Okay, so in this case, we know that our n is 5. So I can write this as 5, choose r, times our a is going to be the 3, and then our b is going to be the negative ax. So a is 3, so I can put this as 3 to the n minus r, times our b. Our b here is negative ax, and this is being raised to the power r. Okay, so we know that we want a term in x cubed, so it means that we have to raise this bracket to the power 3. So in other words, it means that our r is going to be 3. And because r is 3, it means that n minus r, n is 5, so n minus r is 5 minus 3, which gives us a 2. So our power here is going to be a 2. And then we have to replace this r. We know that r is 3, so that's 5, choose 3. Okay, so this is our expression for the term in x cubed. And we can do the same for the term in x to the power 4. We can say that it's going to be of the form n choose r times a to the n minus r times b to the r. So n is 5, choose r, we need to find what r is, times our a is 3, this is to the power n minus r, times our b is negative ax, and this is to the power r. We want a term in x to the 4, so it means we have to raise this bracket to the power 4. So as a result, our r has to be a 4. And so if we've got a 4 here, it means n minus r is going to be 5 minus 4. And so that power there is going to be the power 1. So that's 3 to the power 1, and it means 5 choose r is 5 choose 4. 5 choose 4. So this would be our expression for the term in x to the 4. So let's simplify our coefficients now. Start with 5 choose 3. 5 choose 3 should give you 10, multiplied by 3 squared, which is 9, multiplied by, here we've got negative ax cubed, so make sure to cube the negative a first, so that you have negative a cubed, and then cube the x, so that you've got x cubed. And then we've got plus 5 choose 4. So 5 choose 4 will give us 5. And then we've got times 3. Then we've got negative ax to the 4. So raise negative a to the power 4, that gives you a to the 4. Raise x to the power 4, that gives you x to the 4. And so let's simplify. 10 times 9, that's 90. We've got a negative sign here, so I'll put it here. A cubed, x cubed. And then 5 times 3, that's 15. A to the 4, x to the 4. A to the 4, x to the 4. Alright, so now we can conclude that. Therefore, coefficient of x cubed is, so that's the negative 90a cubed, negative 90a cubed. They did ask for it in terms of a, so you don't have to evaluate a. And then the coefficient of x to the 4 is 15a to the 4. And that would be our final answer. Part B, given that the coefficient of x to the 4 in the expansion of ax plus 7 times 3 minus ax to the 5 is 240, find the positive value of a. Okay, so notice how this 3 minus ax to the 5 is the same bracket in part A. So in part A, we found the terms in x cubed and x to the 4 from this bracket. And so what I'm going to do is I'm going to replace this bracket with its terms in x cubed and x to the 4. I'll explain that in a second. So that we've got ax plus 7 multiplied by this expression over here. Negative 90 a cubed x cubed plus 15 a to the 4 x to the 4. All right. So the question is asking us to find the term in x to the 4 when you multiply this bracket to 3 minus ax to the 5. So what you have to think of is which terms from this first bracket can I multiply to terms in this bracket to end up with something in x to the 4. So for example, I can multiply ax with the term in x cubed here, and I'm going to end up with the term in x to the 4. And I can also multiply the 7 with this term here to end up with the term in x to the 4. That's why we're replacing our 3 minus ax to the 5 with just the terms in x cubed and x to the 4, because those are the only terms that when multiplied with other terms in the other bracket would generate something of the form x to the 4. So like we said, it's going to be ax times the term in x cubed, so ax times negative 90 a cubed x cubed plus 7 times 15 a to the 4 x to the 4. So here we've got negative 90 a times a cubed, so that's a to the 4, x times x cubed, that's x to the 4. Then we've got 7 times 15. What is 7 times 15? That is 105. 105 a to the 4 x to the 4. So if we factor out x to the 4, you end up with negative 90 a to the 4 plus 105 a to the 4 x to the 4. So these are like terms, so we can simplify negative 90 plus 105, which should be 15. And so we can say that 15 a to the 4 x to the 4 is the term in x to the 4. But they want the coefficient, or rather they've told us that the coefficient of x to the 4 is 240. So the coefficient of x to the 4 is 15 a to the 4. So we can say that 15 a to the 4 is equal to 240. In fact, I think let's just take it to the side. We're running out of space here. So we've got that 15a to the 4 is equal to 240. So we can divide both sides by 15. So that you've got 240 divided by 15, which is 16. Okay. And since we want a, you can take the fourth root of both sides or raise them to the power a quarter. That's the same effect. So a is going to be 16 to the power 1 over 4, which would be, technically, because we're taking the fourth root, the solutions you're supposed to have are plus or minus 2. Maybe let me write it in that way because it might not be so clear. Right here, this is the fourth root of 16. And on this side, we are also taking the fourth root of a to the 4. What I want to emphasize is that when you take an even root, all right, so when you take a square root, your solutions are going to be plus or minus. When you take the fourth root, your solutions are also going to be plus or minus. It's just that in this case, we can then go ahead and discard negative 2 because they said find the positive value of a. So we would therefore conclude that a is equal to 2. Number 4, solve the equation 4 sine to the 4 theta plus 12 sine squared theta minus 7 is equal to 0 for theta is between 0 degrees and 360 degrees. So I'm just going to rewrite it. 4 sine to the 4 theta plus 12 sine squared theta minus 7 is equal to 0. Okay, so we can rewrite sine to the 4 theta as sine squared theta squared. So we've sort of factored out a power 2 because 2 times 2 would be 4. Okay, plus 12 sine squared theta minus 7 is equal to 0. So we can say let y equals sine squared theta, so that you can clearly see that what we have here is a quadratic. So wherever there's a sine squared theta, I want you to replace it with y. So you've got 4y squared plus, we've got a sine squared theta there, so 12y minus 7 is equal to 0. And now I hope it should be clear that we've got a quadratic. And this looks like it can be factorized by side. If I put a 2y in either bracket, and then I could do positive 14y minus 2y to give me 12y. Yes, 2y times 7 gives us 14y, and then minus 1 times 2y gives us negative 2y. So you've got 14y minus 2y, which is 12y, and minus 1 times 7 is 7. Basically, if you expand this, you should get back to this expression. So that is the correct factorization. If you're not able to do it by head, you can obviously just do it the longer way of using the AC method, where you're going to split this middle term. Or you could use the quadratic formula, but I recommend that you do get better at factorizing, because it will save you a lot of time, and time is not your friend in that exam. But anyways, I digress. We're saying that here we're going to get 2y minus 1 is equal to 0, and 2y plus 7 is equal to 0. So you get that 2y is equal to 1, y is equal to 1 over 2. And from this equation, you get 2y is equal to negative 7, and y is equal to negative 7 over 2. But remember that y is equal to sine squared theta. So what this means is that we're going to reverse our substitution now. Wherever there's a y, we're going to replace it with sine squared theta. So we're going to have sine squared theta is equal to half, and we're also going to have sine squared theta is equal to negative 7 over 2. And now we can take the square roots on both sides, plus or minus. Don't forget your plus or minus anytime you take a square root. So sine theta is equal to plus or minus root half. And then if you do the same here, you're going to get a problem, because we are trying to get the square root of a negative number. So here you're going to get no real solutions. For now, we can just say no solutions. You will learn that this gives you complex numbers when you do pure 3 maths. So they're technically solutions, but those solutions are considered imaginary solutions. For now, saying no solutions is adequate. Okay, so we have this essentially 2 equations that we can work with. So that sine theta is equal to negative root 1 over 2, and sine theta is equal to positive root 1 over 2. So theta is equal to arcsine of negative root 1 over 2, and theta is equal to, let's punch this into the calculator. What are we in? Are we in degrees? Yes, we're in degrees, 0 to 360. So make sure your calculator is in degrees, and we want arcsine of negative root 1 over 2, and this gives us, that's negative 45 degrees. So I'll just write this as our principal value, because it is our principal value. Principal value is equal to negative 45 degrees, but we want theta to be between 0 and 360 degrees. So if we're just to sketch diagram of what we're looking at. Alright, this will be the theta axis, and this will be the y-axis, and we are dealing with a sine graph. I probably should extend it a bit on the negative side. We'll come back there like that, and then maybe up to there. Okay, so this would be negative 180, this would be 0, that's 180, this is 360. And we found that we've got a point at negative 45 degrees. So negative 45 would be somewhere here at this point here. So do we have any solutions between 0 and 360? It looks like we are going to have two of them. So we're going to have a solution at 180 plus 45 and 360 minus 45. So theta is equal to, we could say 180 degrees plus 45, which gives us 180 plus 45. That gives us 225. 225, and you also get theta is equal to 360. So this other one would be 360 minus 45 minus 45, and theta is equal to 360 minus 45, which is 315 degrees. Okay, alternatively, you can use the formula PV times negative 1 to the n plus 180 n. It will give you exactly the same answers that we got here. So n is just an integer, so it can be 1, 2, 3, and so on. So if you substituted n is 1, just write it on the side at n is equal to 1. It's going to be, our principal value is negative 45. So this is times negative 1 to the power 1 plus 180 times 1. So essentially what you're getting here is 180 plus 45, which is this solution. And then if you went to n is equal to 2, at n is equal to 2, you're going to get our principal value is negative 45 times negative 1 to the power 2 plus 180, and this is times 2. So this would be 360, and this is, because the negative 1 is squared, it ends up being 360 minus 45, which is the solution over here. Now let's check to see if we've got any solutions from this equation. Sine theta is equal to root half. We can solve it here. Sine theta is equal to root 1 over 2. So theta is equal to arcsine of root 1 over 2. So theta is equal to, let's punch that into the calculator. That is arcsine of root 1 over 2. That gives us a 45. So theta is 45. I'll write this as our principal value. Our principal value is 45. And we can check to see if we have any other solutions. 45 degrees would be 90 is here. So 45 would be somewhere there. This is 45. So let's draw a line there. The other solution would be here. That's at 180 minus 45. So we can say that theta is 180 minus 45, and theta is equal to 135 degrees. Alternatively, you can use the formula here at the bottom, PV minus 1 to the n plus 180n. It will work as well. So we can conclude that therefore theta is equal to, what's our smallest value? It's the 45 degrees. Then we move on to 135 degrees, which is the solution here. Then we've got 225 degrees. And then finally, we've got 315 degrees. And that's all the solutions from 0 to 360 degrees. Number 5. In the diagram, the graph with the equation y is equal to f of x is shown with solid lines, and the graph with the equation y equals g of x is shown with broken lines. Describe fully a sequence of 3 transformations which transforms the graph of y is equal to f of x to the graph of y is equal to g of x. So what they're saying is that we are going to start with the solid line graph, and we have to transform it to the broken line graph. So the first thing that you should notice is that the graph y equals f of x started on the right hand side of your y-axis, and now it sort of looks like it's been mirrored. Of course, there are other things that have happened to it, but the first thing that has happened, it looks like it has been mirrored or reflected in the y-axis. So I'm going to just write down reflection in the y-axis, and then we're actually going to reflect it. Reflection in the y-axis. So if we reflect this point, it remains exactly there. If we reflect this point, it just means that its x value is going to become negative. So it comes here. If we reflect this point, it comes here. And then finally, if we reflect this point, that's at 4. So that becomes negative 4. So this is what you're going to have just after the reflection. Okay. And then now after reflecting, if we compare the x values, you can tell that this point here is going to be somehow, we're going to have to force it to be this point here. So this point is at x is 0 and that point is at x is negative 1. If you keep doing the same comparison for every point, you notice that same difference of negative 1. This is at negative 2, this is at negative 1. This is at negative 3, this is at negative 2. So essentially what this means is that we have to translate our graph in the x-axis by negative 1. So translation in the x-axis by negative 1 units. Negative 1 unit. Okay. So we need to shift our whole graph by negative 1 unit. Okay, all right, so now the shift is done. So finally, we have to apply one more transformation because they said 3 transformations. And the x values are now perfect. The only thing we need to sort out are our y values. Because at this point, x is negative 1 and x is negative 1, x is negative 2, x is negative 2, that's fine. The only problem are our y values. So I want you to notice what has happened here. This y value here is at 3 and this y value is at 6. So it looks like our y values have been multiplied by 2. Let's test if this is true. At this point we've got 1, at this point it's 2, so yes, that's true. 1, 2, and at this point that's 2 and this is 4. So essentially what we have to do is to stretch in the y direction or y-axis with a scale factor of 2. So if we multiply, I'll do it in red now. If you multiply the y value here, which is a 3 by 2, you end up at 6. Multiply, this is 1. Multiply 1 by 2, you end up at 2. Multiply 1 by 2, you end up at 2. Finally, multiply 2 by 2, you end up at 4. And you've got the broken line graph, which is y equals g of x. And those are your 3 transformations. Part B, find an expression for g of x in the form af bx plus c, where a, b, and c are integers. Okay, so we're starting from f of x, okay? And the first transformation that we have is a reflection in the y-axis. So what does a reflection in the y-axis do? It simply negates your x values. So here we have positive x values, but when you reflect them, all of them just become negative. So it's going to be negative x. All right. And then the next transformation that we have is a translation in the x-axis by negative 1 unit. So how do we write a translation by negative 1 unit? It's going to be x plus 1. Okay. So it's like this. It's going to be x plus 1, which would read as negative 1 unit, or a translation of negative 1 unit. So essentially, you just take the opposite sign. So it means we're going to replace our x here. Be careful how you replace this. Replace x with x plus 1. So what we have is f of negative x plus 1. All right. And then finally, we have the last transformation, which is a stretch in the y-axis by a scale factor of 2. So this just multiplies at the beginning here. And then just to make sure we've got it in the form that they're looking for, we can expand. So that's negative x, negative 1. And this is g of x. And that will be our final answer. Number 6, the first term of a convergent geometric progression is 10. I'll just write that down. A is 10. The sum of the first 4 terms of the GP, sum of the first 4 terms of the GP is P. Sum of the first 8 terms of the GP is Q. It is given that QP, or rather Q over P, Q over P is equal to 17 over 16. Find the two possible values of the sum to infinity. So the formula for sum to infinity, it's in your MF19, it's A over 1 minus R. So we need to find what A is and we need to find what R is, and we have to use the information they've given us. In fact, we already know that A is 10, so that's fine. This should be 10. And we need to figure out what R is. So we're told that the sum of the first 4 terms is equal to P. Using the formula for sum of first n terms, that's going to be A times 1 minus R to the n over 1 minus R. Okay, so this is the formula for sum of first n terms. So let's substitute it for sum of first 4 terms. So sum of first 4 terms is going to be A, which is 10, multiplied by 1 minus R to the power n, so 4 over 1 minus R, and this is equal to P. And we could do the same for sum of first 8 terms. So that's 10 times 1 minus R to the 8, and this is over 1 minus R, and this is equal to Q. Notice how we've got 3 equations. This is, alright, this 1, this is 2, and this is 3. So we want to use these first 2 equations to get an expression for Q over P, and it's going to be in terms of R. Once we have that expression for Q over P, we just equate it to 17 over 16 and solve for R. So essentially what we could do is to just say Q over P is going to be equal to, alright, so Q is this, 10 times 1 minus R to the 8 over 1 minus R, and we're dividing Q by P. P is this expression over here. So I'll just write it like this, divided by 10 times 1 minus R to the 4 over 1 minus R. So we can invert the right hand side so that it becomes 10 times 1 minus R to the 8 over 1 minus R times, so the 1 minus R comes to the top, and this is over 10 times 1 minus R to the 4. So 1 minus R cancels out with 1 minus R, 10 cancels out with 10, and you end up with 1 minus R to the 8 over 1 minus R to the 4. And notice how we've got a difference of 2 squares in both our numerator and denominator, but we are more interested in the difference of 2 squares in the numerator. A difference of 2 squares for status is a squared minus b squared, which can be expressed as a minus b times a plus b. So I'm saying that we've got 1 squared minus, or focused on the numerator here, so that's going to be minus R to the 4, and this is squared. So your A is going to be 1 and your B is going to be R to the 4. That's the difference of 2 squares. So we can write this as 1 minus, because it's A minus B, 1 minus R to the 4 times A plus B, so 1 plus R to the 4. And the reason we want to do it this way so that we've got things that can cancel out. So 1 minus R to the 8 can be written as that expression. So it's going to be 1 minus R to the 4 times 1 plus R to the 4. And this is over 1 minus R to the 4. So this part cancels out and you end up with 1 plus R to the 4. And remember, all of this is just an expression for Q over P. So this is Q over P. This is also Q over P. So we are saying that Q over P can be written as 1 plus R to the 4. But we also know that Q over P is equal to 17 over 16. All right. And so as a result, it means that 1 plus r to the 4 is equal to 17 over 16. And so you get that r to the 4 is equal to 17 over 16 minus 1, which is 1 over 16. So take the fourth root on both sides. And you get that r is equal to plus or minus, that's going to be 1 over 2. And do we have enough information to disregard one of our r's? Okay, they want two possible values for the sum to infinity, so that's fine. So r is either positive 1 over 2 or r is negative 1 over 2. So going back to our sum to infinity, here I'm just going to write r is equal to plus or minus half. So we can start at r is equal to negative half. Our sum to infinity is going to be that sum to infinity is equal to 10 over 1 minus half. So here that's going to be 10 over, that's 3 over 2. So that's 20 over 3. So our sum to infinity is 20 over 3. And then at r is a positive half, you get that your sum to infinity is equal to 10 over 1 minus 1 over 2. So the sum to infinity is going to be 10 over half, so that's 20. These are our two possible values for sum to infinity. Question number 7. The diagram shows a metal plate A, B, C, D, E, F consisting of 5 parts. The parts B, C, D, and D, E, F are semicircles. The part B, A, L, O is a sector of a circle with center O and radius 20 centimeters, and D lies on this circle. The parts OBD and ODF are triangles. Angles BOD and DOF are both theta radians. Given that theta is 1.2, find the area of the metal plate. Give your answer correct to 3 significant figures. So let's create an expression for our area. Our area is going to be, first we're going to have this sector over here. That's the BAFO sector, going round all the way up to F, and then it comes back here. So it's going to be sector area, plus we're also going to have our two triangles. So we've got two triangles which are equal. They're going to be exactly the same because they've got the same dimensions. So these two triangles have an equal area. So that's going to be times 2 times triangle area. And then finally, we've got our two semicircles, which are also equal. So that's BCD and DEF. Okay, so plus 2 times, those are semicircles, so semicircles, 2 times semicircles. All right, so let's start by finding our sector area. To be able to find our sector area, we use the formula that area is equal to half r squared theta. There should be theta there. The radius of our sector is 20, and we need to find the angle over here that would represent theta in this case. So it's going to be half times 20 squared times our theta. Theta is going to be, we have been told that this angle here, theta, is 1.2. Please don't mistake this theta and the theta they have here. This theta just represents any angle. In fact, I should probably write it as something else so that there is no confusion. Maybe alpha. So we know that theta is 1.2 here and also 1.2 here. And for a complete circle, that's going to be 360 degrees or 2 pi radians. So if we want the angle alpha here, alpha is going to be equal to 2 pi minus 1.2 minus 1.2, because theta plus alpha should add up to 2 pi radians because it forms a complete revolution. So that's 2 pi minus 1.2 minus 1.2, so minus 2.4. That's our alpha. I'll just write it exactly as it is. 2 pi minus 2.4. This should give us the area of our sector. So let's punch that into the calculator. That's 1 over 2 times 20 squared times, that's 2 pi minus 2.4. And this gives us 776.6371. Okay. And then now we need to find the area of one of our triangles. If we get the area of one of our triangles, then we can just multiply it by 2. So we want the triangle area. And here, if I just extract one of the triangles, what we're looking at is something like this. And we've got an angle of 1.2 here. And we know that either side here is 20 centimeters. So we can use the formula half AB sine C to find the area, because we've got the angle between two sides. So we can say that the area of a triangle is half times A would be 20 and B is 20, so half times 20 squared times sine C. C is the angle in between them, which is 1.2. So if we punch that into the calculator, that's 1 over 2 times 20 squared times sine 1.2. All right. And remember, since we've got two triangles, we have to multiply this area by 2. So I'm just going to multiply everything by 2 here. So that would become 8.37. I'll put it to 4 decimal places, so it's 70. And then finally, we need the area of our two semicircles. So for the semicircles, we then need to know the length of the third side on our triangle first. So if we can find this length that I've labeled x, which would be the diameter of our semicircle, then we would be able to find the area of our semicircle. So what we can do is we can use the sine rule to say that we want x, and that's going to correspond to sine of the angle 1.2. So x over sine 1.2. And this should be equal to 20 over sine of. Now notice that because these sides are equal, it means that the triangle that we have is an isosceles triangle. So it means that our base angles here are going to be equal. And we know that the angles inside of a triangle should add up to 180. So if I want to know what this opposite angle to 20 is, I simply have to say pi minus our 1.2 divided by 2. This is going to be our angle. So we can use it as an exact value like this, or you could simplify it. I think just for accuracy's sake, we can just leave it as an exact value. Pi minus 1.2 over 2. Okay, and so at this point, to find x, we multiply both sides by sine 1 over 2, 1.2. So 20 sine 1.2 over sine of, let me bring this up, sine pi minus 1.2 over 2. So if we punch this into the calculator, that is 20 sine 1.2. Let me just make sure my calculator is in radians. So 20 sine 1.2 over sine pi minus 1.2 over 2. This gives us a length of 22.5857, correct to 4 decimal places. So now we have the length of x. So x represents the diameter of our semicircle. So if we've got our semicircle here, we're saying that this whole distance here is going to be 22.5857. 22.5857. So if the diameter is 22.5857, what is the radius? The radius would be half of that. So radius is 11.2928. And so now that we've got the radius, we can then calculate the area of our semicircle. And remember, we've got two of these semicircles, so I'll just preemptively multiply by 2. And so the formula for a semicircle is going to be half pi r squared. Okay. So in essence, the 2 and the half cancel out, because if you put two semicircles together, you essentially end up with a full circle. So we are just finding pi r squared. So we know that our radius r is equal to 11.2928. 11.2928, and this is going to be squared, and we're multiplying by pi. So what does that simplify to? So that is 11.2928 squared, which is going to be, I'll write it as 127.5273, and this is multiplying pi. So this here is the area of our two semicircles. This here is the area of our two triangles. And then at the very top, we've got the area of our sector. So if we add all those areas up, we should get the area of the metal plate. So the area is going to be equal to, what's our sector area? 776.6371. 776.6371 plus the area of our two triangles. Don't know why I have two plus signs. That's 8.3770 plus finally the area of our two semicircles. So that's 127.5273 pi. Alright, I think I made a mistake in evaluating the area of our two triangles. So let me punch that into the calculator. That's 2 times 1 over 2 times 20 squared times sine of 1.2. And this gives us, I think I might have used my calculator in degrees. So be careful there. Make sure that your calculator is in radians before you evaluate the sine, because this angle here is in radians. Okay, so it means that the area of our two triangles here is going to be 372.8156. So what we should have here is 372.8156, and we should get the correct result if we add everything up. 776.6371 plus 372.8156 plus 127.5273 pi. Okay, and this does give us 1550, and that will be our final answer. Yeah, so a lesson here: make sure that your calculator is in radians when you're solving questions in this topic, especially because the formulas here work in radians. So make sure you've converted radians. And to be fair, they also did state that theta is in radians, so watch out for that. Part B says, given instead that the area of each semicircle is 50 pi centimeters squared, find the exact perimeter of the metal plate. Okay, so what they're saying is that okay, I need some of this information. Let's just get rid of all of this on the diagram. They're saying now that the area of each semicircle is 50 what? It's 50 pi. Okay, so this is 50 pi, this is 50 pi. And they want us to find the perimeter. So for perimeter, we can create an expression and say that our perimeter is going to be equal to, firstly, we've got arc BD, right? arc BD plus arc DF. But because these two semicircles are exactly the same, arc DF and arc BD will be the same. So I can just say 2 times arc BD. And then finally, we're going to have this big arc. This is big arc. So plus major arc. So just to be more specific, because the minor arc of BF would be the arc that goes in this direction. It'll be the minor arc. So yeah, I'm just being specific that we want the major arc, not the minor arc. So this is major arc BF. All right, so we need to start off by first finding arc BD. So to find arc BD, we use the formula for arc length, which says that S is equal to R times your angle. Here I'm avoiding to use theta in the formula because it's already being used in the question. I don't want to cause any confusion. So it's R times alpha. Alpha is just representing the angle within that sector. So the radius, we're not going to need the information from part A because they've changed the scenario. So your values from part A are completely void now. You can't use them. We knew in part A that theta was 1.2, but that doesn't apply to part B. So we can essentially just get rid of all of this information from part A and we can start from scratch and figure out what we need to find and how to find it. So we've been given that the area of the semicircle is 50 pi. How do we find the area of our semicircle? It's going to be half, that's pi r squared, and this is equal to 50 pi. So using this information or using this equation, we can find what our radius is. We can say that our radius, or for now, r squared is equal to 50 pi divided by 1 over 2 pi. The pi's would cancel out, then you've got 50 over half, which is 50 times 2, so r squared is equal to 100. And if you take the square root on both sides, you're going to get that r is plus or minus 10, but r represents distance. Distance is going to be positive, so we can disregard negative 10. So it means the radius of our semicircle is 10 centimeters. So in other words, it means this radius from here, it goes up to somewhere here, is going to be 10. But if I complete the diameter all the way up to B, it means this distance is 20 centimeters. If our radius is 10, then our diameter is double the radius, which is 20. So notice how we end up with an equilateral triangle. Here we've got 20 centimeters. Here we've got 20 centimeters. Here we've got 20 centimeters. This will probably become crucial when we now want to find the major arc, the fact that we've got an equilateral triangle. But in terms of our angles, it's going to mean that each angle is going to be a third pi, okay? Because our angles are supposed to add up to 180 degrees or pi degrees, it's going to be 1/3 pi plus a third pi plus a third pi, which adds up to pi degrees. But we'll use this information a little bit later. Now what we want to do is to find arc BD. So we say that arc BD is going to be r times alpha, so S is equal to r, our radius we evaluated to be 10, multiplied by alpha. This is a semicircle, so the angle here is 180 degrees, or pi in this case. So 10 times pi. So it means arc BD is going to be equal to 10 pi. Arc BD is 10 pi. Now we need to find major arc BF. So for the major arc BF, we can now go back to our idea of having an equilateral triangle. Because we've got an equilateral triangle, it means this is also a third pi. This is also a third pi, though we're not really worried about those angles. What we want is theta. We know that theta becomes a third pi, and it means this part is also a third pi. So what does it mean for the angle on the other side? This angle becomes 2 pi, because that's 360 degrees, minus a third pi minus a third pi. So minus 2/3 pi. Okay? because this forms a circle, so all the three angles are supposed to add up to 2 pi radians. So to find the arc length of our major arc BF is going to be, that's our radius. Our radius we know to be 20 centimeters multiplied by our angle, which is 2 pi minus 2/3 pi. So that's 2 pi minus 2/3 pi. If we punch that into the calculator, I can also have it as an exact value. So I can say 20 times, that's 2 minus 2 over 3. So that's 80 over 3 pi. 80 over 3 pi. So we know that major arc BF is going to be 80 over 3 pi. So our perimeter is going to be equal to, that's our arc BD, 2 times our arc BD. So 2 times 10 pi plus major arc BF, which is 80 over 3 pi. I don't know if they wanted an exact value or not. Find the exact. Yes, they want an exact value. Okay, so if we simplify, we're looking at, this is 20 pi plus 80 thirds pi. So that's going to be 20 plus 80 thirds. That's 140 thirds. So our perimeter therefore is going to be equal to 140 over 3 pi. And this is our final answer. Question number 8. Express 3x squared minus 12x plus 14 in the form 3x plus a squared plus b, where a and b are constants to be found. Alright, so let's start by factoring out at 3 from the first two terms. So that's going to be 3, and you've got x squared minus, if you factor out at 3 from 12, you get 4. That's x plus 14. And we want to complete the square for x squared minus 4x. So this becomes 3. Then you've got x minus 2. That's squared minus 4 plus 14. And now let's multiply through to get rid of our square brackets. So 3 times x minus 2 squared. That's 3x minus 2 squared. 3 times negative 4. That's negative 12 plus 14. So we get that the final answer should therefore be 3x minus 2 squared plus 2. The function f of x is 3x squared minus 12x plus 14. Okay, so notice how this is that. Is defined for x is greater than or equal to k, where k is a constant. Find the least value of k for which the function exists. Alright, so let me just sketch out on a diagram what we're looking at. That would be, this is our y-axis, need a straight line. So this is our y-axis, this is our x-axis, and we are looking at a turning point of 2, 2. Because if you read out the coordinates of the turning point there, they're going to be 2, 2. And we know that our term in x squared has a positive coefficient. So we're looking at this shape over here. Okay, and their question is, at what value of k are we going to have an inverse function? The smallest value rather. So we know that for an inverse function to exist, we must have a one-to-one function. So what a one-to-one function is, you can check using the horizontal line rule test. So if a function is one-to-one, if we draw a horizontal line at any given point, we should only have one point of intersection. But if you check with the function that we have here, we've got 2 points of intersection. So if we want the domain x is greater than or equal to k, obviously it means that we are moving to the right. So they want to know what's the smallest value of k that you're going to have a one-to-one function. So if, for example, let me just get rid of this horizontal line and these circles. So say if, for example, we decide, okay, we just want to take this part of the graph, right? Obviously, this is one-to-one because at any given point, we're only intersecting once. That's fine. But the problem is this is not going to give us, at this point, this is not going to be the least value of k. The least value of k is going to be at the turning point, because as soon as you go beyond the turning point, now we start to have 2 points of intersection. So at the turning point, that's going to be our least value of k. So x is going to be greater than or equal to, we say the coordinates of our turning point are 2, 2. So x is greater than or equal to 2. So we can say that the least value of k, least k is equal to 2. For the rest of this question, you should assume that k has the value found in part B. So we should assume that k is equal to 2. Okay. So that means x is greater than or equal to 2 here. Part C says find an expression for f inverse of x. So we know that our function f of x is equal to 3x squared minus 12x plus 14. If we want to find its inverse function, we prefer to have this in the completed square form. So I'll write f of x as 3 times x minus 2 squared plus 2. And then our goal now is to obviously get the inverse function. The way we do it is by first replacing f of x with y. And now we have to find a way to make this x subject of the formula, because that then gives us the expression for our inverse function. So let's start off by subtracting 2 from both sides. You get y minus 2 is equal to 3x minus 2 squared. And then divide both sides by 3. So you get y minus 2 over 3 is equal to x minus 2 squared. Take the square root on both sides, and remember we get plus or minus. So what we have is x minus 2 is equal to, that's plus or minus the square root of y minus 2 over 3. Then add 2 to both sides, so x is equal to 2 plus or minus the square root of y minus 2 over 3. And we have to pick a sign. We can't have both signs. And the way we're going to pick our sign is to use our domain. Because our domain has a greater than or equal to sign, it doesn't matter if it's just greater than, as long as we see that greater than part, we're going to pick the positive sign there. If it was less than or equal to, you would pick the negative sign. So in this case, we're picking the positive sign. So we can conclude that therefore, f inverse of x is equal to 2, and we said we're picking the positive sign, plus the square root of, now instead of writing it as y, you're going to write it as an x, so x minus 2 over 3. And this would be your final answer. Now part D says hence or otherwise solve the equation f of x is equal to 29. Now the key word here is hence. That implies that we're supposed to use information from a previous question to help us in solving this question. So what do we do in the previous part of this question? We found the inverse. So can we use the inverse function to maybe simplify this calculation for us? Yes, we can. So we can apply the inverse function on both sides so that it's f inverse of f of x. And what you do on one side, you do on the other, so f inverse of 29. And the idea we want to use here is that if you apply f inverse to f of x, you're going to get an x. Let's maybe highlight that in red. That's x, that's x. So what happens is that this f cancels out the f inverse. So if you look at it in this context, what's going to happen is that f inverse will cancel out this f, and you remain with f of x. So in other words, what we've got is that f of x is equal to f inverse of 29. Okay, and we can evaluate f inverse of 29 using this. So f inverse of 29 is going to be equal to 2 plus the square root of 29 minus 2 over 3. So let's punch that into the calculator. That's 2 plus the square root of 29 minus 2 over 3, and that is a 5. So f inverse of 29 is equal to 5. Okay, so it means that the equation we're solving is simply f of x is equal to 5. So what is our f of x here? Okay, f of x is 3x squared minus 12x plus 14. Now, do we use the completed square form or do we use the expanded form? Which would be easier? Let's use the completed square form. So f of x is 3x minus 2 squared plus 2. So let's write that down. 3x minus 2 squared plus 2 is equal to 5. Okay, so now let's solve for x. So subtract 2 from both sides. You've got 3x minus 2 squared is equal to 3. Divide both sides by 3. You've got x minus 2 squared is equal to 1. Take the square root on both sides. Remember that this is plus or minus. So you've got x minus 2 is equal to plus or minus 1. So you get x is equal to 2 plus or minus 1. So x is either that's 1 or x is 3. And now let's check if both these values fit within our domain. Our domain is x is greater than or equal to 2. So which values fit within that domain? So the only value that fits here will be x is 3 because our x is 1 is less than 2. So we can conclude that therefore x is equal to 3, and that's our final answer. Number 9. The diagram shows the curves with equations y is equal to x cubed minus 3x plus 3 and y is equal to 2x cubed minus 4x squared plus 3. Part A. Find the x-coordinates of the points of intersection of the curves. Okay, so we've got the curve with equation y is equal to x cubed minus 3x plus 3, and then we have the curve with equation y is equal to 2x cubed minus 4x squared plus 3. And we want to find their points of intersection. So if you want points of intersection, you have to solve simultaneously. So in this case, since both of them are in terms of y, we can simply equate the right-hand sides together so that it's x cubed minus 3x plus 3 is equal to 2x cubed minus 4x squared plus 3. All right, so let's move everything to the right-hand side. I'll start with writing 2x cubed. Then if we move x cubed to the right, it becomes negative x cubed. We've got negative 4x squared. If we move negative 3x, it becomes positive 3x. Then we've got this positive 3. If we move this 3, it becomes negative 3, and this is equal to 0. So what we have is 2x cubed minus x cubed, which gives us positive x cubed. Then we've got minus 4x squared plus 3x. Then 3 minus 3 gives us a 0, so this is equal to 0. Now we've got a cubic equation, but we can factor out x so that we don't have to try to solve a cubic equation. So that's x times x squared minus 4x plus 3 is equal to 0. So either x is 0 or this whole equation is 0. And by the way, do not divide through by x. Whenever you think of dividing through by a variable, I want you to instead factor out that variable. Because if you divide through by a variable, you're going to lose the solution. So in this case, we're getting x is 0. Will it be useful in this case? Yes, it's actually one of the coordinates of the points of intersection. So yes, it does matter. So x is 0 here, and we also get that the quadratic itself is 0. X squared minus 4x plus 3 is equal to 0. So let's solve our quadratic. I think we can factorize it by side. Yes, x minus 3, x minus 1 is equal to 0 minus 3 times minus 1 is positive 3. Okay, so here we get that either x is 3 or x is 1. Now let's see our points of intersection. There are 3 points of intersection here. There's this first point of intersection that we got from x is 0. And then there's the next point of intersection that would be at x is 1. So this is 0, this is 1. And the final one is at x is 3. So somewhere there we must have x is 3. Those would be our three answers. Let's just conclude at the bottom. X is 0, X is 1, X is 3. Part B says find the area of the shaded region. Okay. So to get the area of the shaded region, we have to integrate. So it's going to be, we're integrating from this point, so from 1 all the way up to the other point of intersection, which is 3. And the way we're going to do this is we're going to say the area of the curve on top minus the area of the curve on the bottom. That should give us the area in between the curves. So if I'm to color code it, it's going to be the area of this curve that's on top all the way up to here minus the area of this curve that's on the bottom. Okay. And because the limits are going to be the same here, we can just combine them. So the curve that's on top is this curve. So let's write it in. It's going to be x cubed minus 3x plus 3. And then we're going to subtract the area of this other curve. So that's 2x cubed minus 4x squared. That's 3. And maybe let's just put big brackets here to show that this is all with respect to x. Okay. Now, alternatively, you could separate the integrals like this to say that the area of the curve on top is going to be, maybe let me write it with the correct color. To say that the area of the top curve is the integral from 1 to 3 of this expression, x cubed minus 3x plus 3 with respect to x minus the area of the curve on the bottom from 1 to 3, so 2x cubed minus 4x squared plus 3. But because the limits are the same, we can combine them and put them under one integral sign. Okay. So here, let's simplify. If we expand this bracket, we're going to have, this is the integral from 1 to 3. That's x cubed minus 3x plus 3 minus 2x cubed minus 4x squared, so plus 4x squared minus 3. Minus 3, this is all with respect to x. So simplify again, 1 to 3. X cubed minus 2x cubed, that gives us negative x cubed. Then we've got a positive 4x squared, got negative 3x, then 3 minus 3 cancels out, and this is all with respect to x. Now if we integrate, negative x cubed becomes negative x to the 4 over 4 plus 4x cubed over 3 minus 3x squared over 2. Our limits are from 1 to 3. And now we can go ahead and substitute in our limits. So we've got negative 3 to the 4 over 4 plus 4 times 3 to the 3 over 3 minus 3 times 3 squared over 2 minus, and this is going to be the lower limit, so minus, that's 1 to the 4 over 4 plus 4 times 1 to the 3 over 3 minus 3 times 1 squared over 2. All right, so let's punch this expression into the calculator. So that's negative 3 to the 4 over 4 plus 4 times 3 to the 3 over 3 minus 3 times 3 to the 2 over 2, and that gives us 9 over 4 minus our lower limit, so that's minus 1 to the 4 over 4 plus 4 times 1 to the 3 over 3 minus 3 times 1 to the 2 over 2, and this gives us minus 5 over 12. So that's 9 over 4 plus 5 over 12, which gives us 8 over 3. and that is the area between our two curves. Number 10, points A and B have coordinates 4, 3, and 8, -5 respectively. A circle with radius 10 passes through the points A and B. Part A, show that the center of the circle lies on the line y equals half x minus 4. Okay, so we've got a circle, and so far what we know is that we've got points A and B. I'm going to put A somewhere here, and A has coordinates 4, 3. So let's just label that this is 4, 3, and this is the point A. And then we've also got point B, which has coordinates 8, -5. So 8, -5. Let's put it somewhere. Let's put it here. Why not? B, 8, -5. And they want us to show that the center of the circle lies on the line y equals half x minus 4. So the idea that we want to use is that if I join points A and B, this forms the chord AB. And there is a rule that says the perpendicular bisector of any chord passes through the center of the circle. So the perpendicular bisector of our line AB is going to pass through the center of the circle. And so this is likely going to be the equation of our perpendicular bisector. And so simply all we have to do is to find the equation of this green line. If we find the equation of this perpendicular bisector, we know that it's going to pass through the center, because there's a rule that says that a perpendicular bisector of a chord will pass through the center of the circle. All right. So how do we find the equation of a perpendicular bisector? Well, a perpendicular bisector is simply a straight line. To find the equation of a straight line, you need two things. You need a point that lies on that line, as well as the gradient of that line. So let's start with the gradient of our perpendicular bisector. Since it is perpendicular to line AB, we can first find the gradient of AB and then use that to get our gradient. So the gradient of AB is going to be the change in y. So I'll do minus 5 rather, minus 3, minus 5 minus 3 over 8 minus 4. 8 minus 4. So this is -8 over 4, which is going to be -2. And so we know that for perpendicular lines, m1 times m2 is equal to -1, which means that m1 would simply be -1 over m2. And in our case, saying that m1 is the gradient of our perpendicular bisector, m1 is going to be equal to -1 over the gradient of AB, -2. So you get that the gradient of our perpendicular bisector is equal to 1 over 2. Now, the other thing that we need is a point that lies on our line. So since this is a perpendicular bisector, it means that it passes through the midpoint of AB. So if we can find the coordinates of the midpoint of AB, we can use that to get the equation of our perpendicular bisector. So to get the midpoint, it's just the average of your x values, so x1 plus x2 over 2, and the average of your y value, so y1 plus y2 over 2. So let's do that. So x1 is 4 plus x2 being 8 over 2, and then y1 is 3 minus 5 over 2. And so we get that the coordinates of our midpoint are going to be 4 plus 8, that's 12 over 2, that's 6. 3 minus 5, that's minus 2 over 2, that's minus 1. All right. So now we've got the gradient of our perpendicular bisector as well as a point that lies on our perpendicular bisector. So let's use y equals mx plus c. So we know that our gradient m is going to be 1 over 2, and it passes through the midpoint with coordinates 6, -1. All right. So let's substitute so we can evaluate our constant c. So our y value is going to be -1 is equal to m, which is half, x, which is 6, plus c. So you get -1 is equal to, that's half of 6, so 3 plus c. So you get c is equal to -1 minus 3, which is -4. And so therefore the equation of our perpendicular bisector is y is equal to half x minus 4. And I believe that's the equation they have here. Yes, y is half x minus 4. To conclude, we can say that y equals half x minus 4 is perpendicular bisector of chord AB. Hence, the center of the circle lies on this equation. Center of circle, how do they word it? Hence, the center of the circle lies on this line. Hence, the center of the circle lies on this line. Okay. So that's part A done. Now part B says find the two possible equations of the circle. Okay, so this is an interesting one. We know that our circle lies on the line y equals half x minus 4. And we know that our circle takes the form x minus a squared plus y minus b squared is equal to r squared. I believe they gave us the radius. So our circle is radius 10. So this should be equal to 10 squared. Okay. Using this equation, we can get the general coordinates of the center of the circle because we know that the center of the circle lies on this line. So if we said, for example, we could say that x is equal to a. All right, we need to get the y coordinate. So let's substitute into this equation. That will be y is equal to half a minus 4. So it means that our center has the coordinates a, half a, minus 4. These are the general coordinates of the center of the circle. And essentially, this would be the general coordinates for any point that lies on this line. The only thing that would differ is the value of a at that specific point. So to get the actual coordinates of our center of the circle, we need to figure out what a is. And we can do that by substituting these coordinates into our equation of the circle. So this would become x minus, I've said x is a, so this can remain as a squared. Because remember that if you've got your equation of the circle in this form, your center is ab. So this is the x coordinate and this is the y coordinate. So I've simply substituted this a here plus y minus b. So our b would be the y coordinate. So that's in brackets. Be careful with your negative sign there. So half a minus 4 and this is squared is equal to 10 squared. All right. Maybe here I think it might be easier for us to expand if we just leave this part like that. So I'm not going to expand that part right now. And now what we can do is we were given 2 points that lie on our circle, right? So we can use one of them. We know that the point A with coordinates 4, 3 lies on our circle. So we can come up with an equation using this point. So at A, x is 4 and y is 3. So we can substitute x with 4. So this 4 minus a squared plus our y is going to be 3. So 3 minus as half a minus 4. And this is squared is equal to 10 squared, which is 100. And now I hope you can see that we've got an equation in terms of a, which we can solve and find a. Once we have a, we can get the exact coordinates of our center and therefore the actual equation of our circle. And they say 2 possible equations, so we're going to get 2 values of a. All right, so let's do that. What we have to do is to expand. So let's start by expanding this bracket here. So square the negative a, you get a squared. Then 2 times 4 times negative a gives us negative 8a. Square the 4, you get a 16. Plus, and then here we're going to do the same. So square the 3, that's 9. And then 2 times 3 times negative this bracket. So that's negative 6, and then you've got your bracket. half a minus 4. And okay, so I still going to have trouble with that bracket. So finally we have to square this, and if you square that, that's going to be half a. Remember, the negative sign will be squared, so it becomes positive. So it's just half a minus 4, and this is squared. This is all equal to 100. Alright, so let's deal with this. So we've got a squared minus 8a. We've got 16 plus 9, which is 25. And we can expand this. So minus 6 times half a gives us minus 3a. Minus 6 times minus 4 gives us positive 24. And then here, square the half, you get a quarter. Square the a, you get a squared. Then 2 times half a gives us a, times negative 4, that's negative 4a. Then square the negative 4, that's positive 16, and this is equal to 100. Now let's simplify like terms. So we've got a squared plus a quarter a squared, that gives us 5 over 4a squared. Then we've got negative 8a, negative 3a, that's negative 11a, and negative 4a, that gives us negative 15a. Then here we've got 25 plus 24, which gives us 49, plus 16, 49 plus 16, that gives us 65. And then I'll bring the 100 to this side, so minus 100 is equal to 0. And so what we have is 5 over 4a squared minus 15a. Then we've got 65 minus 100, which is minus 35, is equal to 0. So for starters, we can multiply through by 4 to get rid of this denominator here. So we'd end up with 5a squared minus 60a minus 35 times 4, which is 140. And all of this is divisible by 5, so we can also divide through by 5. So we end up with a squared minus, that's 12a, minus, that's going to be 28, is equal to 0. And can we factorize this by side? Can we? Yes, we can. 14 and 2, specifically negative 14 plus 2 gives us negative 12, and then 2 times negative 14 gives us negative. Okay, that's fine. So we get that either a is equal to negative 2 from this bracket, or that a is equal to 14. All right, so here's what's happening now. So at a is equal to negative 2, it means that the coordinates of our center are going to be, the x coordinate is a, so negative 2, and the y coordinate is half a, so half times negative 2, negative 4. So the coordinates here would be negative 2, half times the 2 cancel out, so you end up with negative 1, negative 4, which is negative 5. So here you'd get that the equation of the circle is x minus minus 2, so x plus 2 squared plus y minus minus 5, so y plus 5. This is squared, and this is equal to our radius, which was our radius squared, which is 10 squared over 100. Okay, and then the second possible outcome is at a is equal to positive 14. At a, not at equals, at a is equal to 14. So here we'd get that our a is 14, and then half times 14 minus 4. So this is 14, half of 14 is 7, minus 4 is 3. Okay, so our coordinates of the center here are going to be 14 and 3. So we get our equation in this case to be x minus our 14, and this is squared, plus y minus our 3, this is squared, and this is all equal to our radius squared, which is 100. And these are the two possible equations of our circle, and that is our final answer. Number 11, the equation of a curve is y is equal to kx to the half minus 4x squared plus 2, where k is a constant. Part A, find y dx and d squared y dx squared in terms of k. Alright, so we are just differentiating. We're finding our first derivative and our second derivative. And I know that most students struggle when they put a constant. I want you to think of k as just another number. So think of this as y is equal to 2x to the half minus 4x squared plus 2. So I want you to differentiate this term normally like you would. You bring down your half, you're multiplying 2, you've got x, subtract 1 from half, is going to be negative half. Do not try to differentiate the k. Okay, k is a constant, it is not a variable. We are differentiating x, not k. Alright, so we've got, let me just remove that. We've got y is equal to kx to the half minus 4x squared plus 2, so it means our dy dx is going to be, so bring down the half, and we're multiplying k, x, subtract 1 from half, you get negative half. Minus 4, bring down the 2, x, subtract 1 from 2, you get a 1. Then you've got a constant, you differentiate a constant, you get 0. So it means our dy dx is going to be, this is half k x to the negative half minus 4 times 2, so 8x to the power 1. This is our dy dx. Now let's find our second derivative, d squared y dx squared. Okay, so we'll start with this term. So we've got our half, and I want you to bring down, maybe let me write k as well, and I want you to bring down the negative half, so negative half, and then we've got x, subtract 1 from negative half, you're going to get negative 3 over 2, and then differentiate negative 8x, you just get negative 8. So it means our second derivative is going to be equal to, so half times negative half, that's negative a quarter, k x to the negative 3 over 2 minus 8. And this would be our final answer. There's our dy dx and our d squared y dx squared. Part B, it is given that k is 2, find the coordinates of the stationary point and determine its nature. So to get the coordinates of a stationary point, it means that dy dx is 0. At a stationary point, dy dx is 0. So we need to solve that equation. And we now know that k is 2. So we can rewrite our dy dx as half times k, which is 2x to the negative half minus 8x, and this should all be equal to 0. So the half and the 2 will cancel out, and so I'll rewrite this with a positive power. So that will be 1 over x to the power half minus 8x is equal to 0. And now let's get rid of our denominator. So multiply through by x to the half. So that's just going to be 1 minus, if you multiply x here by x to the half, remember this is technically x to the power 1. Since our base is the same, you add 1 plus half, you should get 3 over 2. So we've got 1 minus 8x to the 3 over 2 is equal to 0. And so let's solve for x now. This is 8x to the 3 over 2 is equal to 1. So x to the 3 over 2 is equal to 1 over 8. Raise both sides to the power 2/3 so that this cancels out. And you should get that x is equal to, let's punch that into the calculator. This is 1 over 8 to the power 2/3. And that gives us a quarter. So x is a quarter. So what is our y coordinate? To get the y coordinate, we use the equation of the curve. Remember that k is 2, so this is 2x to the half minus 4x squared plus 2. And we just found that x is a quarter, so y is equal to 2 times a quarter to the half minus 4 times a quarter squared plus 2. And so we get that y is equal to, so this is 2 times a quarter, and this is to the power half, minus 4 times a quarter, and this is squared, plus 2, this gives us 11 over 4. So the coordinates of our stationary point are going to be a quarter, 11/4. Okay, so these are the coordinates of stationary point. But we also have to determine the nature of our stationary point. And to do that, we have to use our second derivative, which we found in part A. Okay, so our second derivative, remember here we're still working with k is 2. Our second derivative is equal to negative a quarter times 2x to the negative 3/2 minus 8. And so d squared y dx squared is equal to, that's negative 1/2x to the negative 3/2 minus 8. All right. And we want to evaluate this at x is a quarter. So when x is 1/4, what is our second derivative equal to? So that's negative a half times a quarter to the negative 3/2 minus 8. Punch this into the calculator. Negative a half times a quarter to the power negative 3/2 minus 8. And this gives us negative 12. Okay, so we can conclude that therefore our second derivative is equal to negative 12, which is less than 0. Hence, our stationary point, a quarter, 11/4, is a maximum point. Maximum point. Okay, so if your second derivative is negative, you've got a maximum point. If it's positive, you've got a minimum point. Part C says points A and B on the curve have coordinates 0.25 and 1 respectively. For a different value of k, the tangents to the curve at the points A and B meet at a point with x coordinate 0.6. Find this value of k. Okay, so we're no longer dealing with k is 2. And I'm just going to draw a diagram to illustrate what's going on here. This is not an exact function. This is not an exact sketch. So I'm not going to try to replicate whatever function we have here. I'm just going to draw a quadratic curve just so we get the idea. So what we have is something like this. And then we've got a point A and a point B. We know that at the point A, our x coordinate is 0.25. Right? This is what we know so far. And then at point B, our x coordinate is going to be at B 1. Okay, our x coordinate is 1. That's what we know so far. All right. And then we've got tangents at these points, right? So we've got a tangent at A, and then we've also got a tangent at B. All right. And we're told that at the point at which these tangents, let me put that in blue, at the point where these tangents intersect, where they meet, the x coordinate here is going to be 0.6. We don't really know what the other value is. So to solve for k, what we can do is to find the equations of our tangents. And then we know that the point of intersection of our tangents is going to be at x is 0.6. So we replace x with 0.6, and that should give us an equation in k, and we can just solve for k. All right. So if you didn't get the full picture, don't worry, we'll walk through it step by step. All right, so for starters, let's find the equation of the tangent to A, so the red tangent. Remember, the tangent is just simply a straight line. So for a straight line, you need two things. You need a point that lies on that line as well as the gradient. So we know that this tangent goes through the point A, and we have the x coordinate of A. Since A lies on the curve, we can get its y coordinate as well. So at A, we're saying that x is 0.6, right? 0.25, my bad. So at A, x is 0.25. Let's substitute that into the equation of the curve to get the y coordinate. So that's y is equal to k 0.25 to the half minus 4 times 0.25 squared
and this is plus 2, so we get that y is equal to, so what is 0.2 to the half? That's a quarter to the half, which gives us a half. So we've got half k, and then let's evaluate that part as -4 times 0.25 squared plus 2, that gives us 7/4. So the y coordinate at A is half k plus 7/4. All right, so let's fill that in there. This is going to be half k plus 7/4. These are the coordinates of A. Okay, and we might as well just get the y coordinate of B at the same time as well, so that we don't have to keep going up and down. So let's just find the y coordinate. Since B also lies on the curve, we can just substitute x with 1 to get the y coordinate at B. So at B, we know that x is 1, so we substitute 1 into our equation. That's y is equal to k times 1 to the half minus 4 times 1 squared plus 2. So you end up with y is k, then minus 4 plus 2, so that's minus 2. So at B, our y coordinate is k minus 2. K minus 2. Okay. So that's k minus 2. All right. Back to our problem. We were interested in getting the equation of the tangent at A. And we said since it's a straight line, we need a point that lies on our line as well as the gradient of that tangent. So we now have a point that lies on that line, and that point is A, but we need the gradient. So because this is a tangent at A, we can just get the gradient of the curve at the point A, and that's going to be the gradient of the tangent. And to do that, we can use dy dx. So what was our dy dx from earlier? It's half kx to the negative half minus 8x. Half kx to the negative half minus 8x. Let's double check. Yes. And we want to evaluate this at the point A. So when x is 0.25, and this is half k plus 7/4. We're interested in x. So substitute x with 0.25. That's half k times 0.25 to the negative half minus 8 times 0.25. So that's half times 0.25 to the negative half, which would give us k here. And then minus 8 times 0.25, so a quarter of 8, which is 2. So k minus 2. Alright, so this is the gradient of the tangent at A. So we can now find its equation using y equals mx plus c, because we know that m is k minus 2, and then the coordinates, or using the coordinates for the point A, 0.25 half k. In fact, let me just write it as a quarter, because everything else is a fraction, not a decimal. So a quarter and half k plus 7/4. So we need to substitute into this equation here so we can evaluate our constant c. So that's going to be y, our y values here. So half k plus 7/4 is equal to m, which is k minus 2. And this is being multiplied by x. X is a quarter. And this is plus c. Okay. So what we have is half k plus 7/4 is equal to, expand that, that's a quarter k minus a half. 2 times a quarter is a half, plus c, so c is equal to half k minus a quarter k plus 7/4. Then when this moves there, it becomes positive, so positive 1/2. Alright, so let's simplify. C is going to be half k minus a quarter k, that's a quarter k. 7/4 plus half. What is 7/4 plus half? That's 9/4, isn't it? I should trust myself a little bit more. Yes, that's 9/4. All right, and then we get here that the equation of tangent at A is y is equal to, what's our m? Our m is k minus 2, k minus 2x plus our constant, our y-intercept, a quarter k plus 9 over 4. Okay, so this is the equation of the tangent at A. Now we need to find the equation of the tangent at B, which is the green line. So again, because this is a straight line, we need two things. We need the gradient as well as a point that lies on that line. And so in this case, our point is the point B. We just need to find the gradient at B. So that's dy dx at B. So in this case, dy dx is going to be equal to, a half k, and then remember we're using this, but at B, times x, our x is 1, to the negative half minus 8x, x is 1, so this is at B. So dy dx is equal to, this is half k minus 8. So the gradient for the tangent at B is half k minus 8. We can go ahead and find the equation using the form y equals mx plus c. We know that our gradient is half k minus 8, and our point is point B, which has coordinates 1 and k minus 2. K minus 2. All right, so let's substitute in here. Our y value is k minus 2, and this is equal to m, which is half k minus 8, times x is 1, plus c. So we've got k minus 2 is equal to half k minus 8 plus c. So c is equal to k minus our half k minus 2. And when this goes there, it becomes positive. So we have that c is equal to k minus a half k is going to give us a half k. Then minus 2 plus 8 gives us a positive 6. So the equation of tangent at B is y is equal to, what is m, half k minus 8 x plus our y-intercept, which is half k plus 6, plus half k plus 6. Okay, all right. So going back to our diagram, we say that we want to find the point of intersection of these two tangents, and we know that at that point of intersection, x is 0.6. Okay, so let's solve our two tangents simultaneously, and then once we've simplified them, we are going to substitute x with 0.6 because we know that the point of intersection has an x coordinate of 0.6. So we can just go ahead and equate the two. So we've got this one, k minus 2x plus a quarter k plus 9 over 4, and this is equal to this part, that's half k minus 8x plus half k plus 6. I think here we'd probably be better off just substituting x straight away. I don't think it helps to try to simplify this further. I mean, we could try, but I'm not interested. So what is 0.6 as a fraction? This is 0.6. X is 0.6 at the point of intersection. So we can replace x with 0.6 in this equation, because if you resolve this equation, it gives you the points of intersection. Okay, so this is at x is 0.6, which I'll write as a fraction. So at x is 3 over 5. We've got k minus 2 times 3 over 5 plus a quarter k plus 9 over 4 is equal to a half k minus 8 times 3 over 5 plus a half k plus 6. Okay, let's expand this. That's going to be 3 over 5k. Then 3 over 5 times -2, so -6 over 5 plus 1/4 k plus 9 over 4 is equal to 3 over 5 times half k, so that's going to be 3 over 10 k minus 8 times 3 over 5, so that's 24 over 5 plus half k plus 6. All right, let's simplify like terms. So here I see 3 over 5k plus 1/4 k, so that's 3 over 5 plus 1 over 4. That gives us 17 over 20k. Then here we've got -6 over 5 plus 9 over 4. So -6 over 5 plus 9 over 4 gives us 21 over 20. And this is equal to, let's deal with the like terms on this side. So 3 over 10k plus a half. So that's going to give us 8 over 10, which is 4 over 5. So 4 over 5k. Then we've got -24 over 5 plus 6. So -24 over 5 plus 6, that's going to be positive 6 over 5. So positive 6 over 5. And then let's put this term this side. 17 over 20k minus 4 over 5k is equal to 6 over 5. And then move this that side. So minus 21 over 20. So on the left here, we have that 17 over 20 minus 4 over 5 is 1 over 20. So this is 1 over 20k is equal to, that is 6 over 5 minus 21 over 20, which is 3 over 20. So to get k, multiply both sides by 20. And you should get that, therefore, k is equal to 3, and that is our final answer. And that is the paper as well. Okay, I hope you guys found this solution useful. If you did, please leave a like on the video, subscribe for more videos like this, share this video with your friends, let's pass together, and comment down below which paper would you like to see me break down next. All the best with your exams, bye bye.